let us discuss this small result. So we have to prove that in a discrete matrix space, every Cauchy sequence is convergent. This thing we have to prove. Okay. So see, you are familiar with a discrete matrix space. In a discrete matrix space, there are only two distances, 0 and 1. If two elements are same, distance between them is 0 obviously. And if two elements are distinct, distance between them is 1, that is fixed. Okay. So we have to prove every Cauchy sequence is convergent. So here I have assumed let Xn be a Cauchy sequence in matrix space XD. We have to prove that it is convergent. So if it is Cauchy, so therefore for epsilon is equal to 1 by 2, there exists n belongs to set of natural number such that, see, I am using definition of Cauchy sequence, but epsilon, I have taken a fixed epsilon which is 1 by 2. So therefore what can we write? This is d of xn xm less than epsilon is 1 by 2 for all nm greater than or equal to capital N. See, in particular, we take m is equal to capital N. So here we have n and m. Now in particular, what will I do? I will take m is equal to capital N. Then what can we write here? So therefore d of xn x capital N less than 1 by 2 for all n greater than or equal to capital N. Since we have fixed m, so m cannot vary, it is fixed capital N. So small n can vary here. Distance is less than 1 by 2. So as I told you earlier, there are only two possibilities, either distance 0 or distance 1. It is less than 1 by 2, that means obviously distance is 0. So therefore distance of xn x capital N is equal to 0 for all n greater than or equal to capital N. See, distance between 2 points is 0, that means both of them are equal. So therefore xn is equal to x capital N for all n greater than or equal to capital N. Okay, so all elements are equal to x capital N. I will call it as p. Let xn is equal to p. So I am calling it as p. So therefore, what can we write? Xn is equal to p for all n greater than or equal to capital N. Just for simplicity, I use xn is equal to p here. So therefore, what can we write? Xn is equal to p for all n greater or equal to capital N. So therefore, sequence will be like this. Xn, you know there are distinct terms x1, x2 and so on, xn minus 1. But from xn, from n, capital N, we will have all terms p. Remaining terms p, infinite times. So now we are going to prove, yes, this sequence xn converges to p. Now, we will prove that this sequence xn converges to p. Okay, since we have to prove now every Cauchy sequence is convergent, so we are going to prove it is converges to p and hence it is convergent. What will I do? Let epsilon greater than 0 be given. I have taken one epsilon. After that, let, okay, or for capital N belongs to set of natural number. Already we have some capital N. I am using the same capital N here. See, there is no more space to write, so make a screenshot of it, then we will go further. See, for n greater than or equal to capital N, I am considering d of xn comma p. But we know that we have a sequence like this, x1, x2 and so on, xn minus 1, and remaining terms are p, all terms are same, p. So therefore, if n is greater than capital N, value of xn is p. So therefore, d of p comma p. If both elements are equal, then distance between them is 0. And obviously, 0 is less than epsilon. So therefore, what we get? D of xn comma p less than epsilon for all n greater than or equal to capital N. This is the definition of convergent sequence. So therefore, sequence xn converges to p. So therefore, sequence xn is convergent. Therefore, sequence xn is convergent. Let me remove this one, it is not required now. Okay, so therefore, we have taken one Cauchy sequence of that discrete matrix space and we proved that it is convergent. So therefore, every Cauchy sequence is convergent in a discrete matrix space. Okay, make a screenshot of it. After that, we will stop. Thank you. Bye bye.